So what you want to do is the same thing, BRVM and what? BRVM CI, right? And SOF. So try and change those things at those points. Where you see SA is BRVM CI. And go this XOF. So as we are editing this code, see if you are writing your paper, you have your data set, and you want to modify the code. This is exactly what you do. It's not a lot. BRVM XOF. BRVM, no, CI. So, okay, now last one, BRVM. Then what XOF. So let's see what we are trying to do here. What you want to do is you want to check the quantile regression against the OLS and see where the differences are. So I think you should look here first. No, just leave them. We are only changing the variables. So here I want to plot the points. You can change this label, it doesn't matter. Okay. We want to plot the points. When we finish, want to give it a color. I want to put a straight line. Watch carefully here. A straight line of a quantile regression through the middle. That's why our tau is 50. So all this being equal, that should be the same as the OLS. Okay, then we do OLS. See here, we have not specified any quantile because it's OLS. LM here. After that, we just want to plot the 19 quantiles for the data. Okay. So this one is what I want you. I don't want you to select all of them around. You should run them line by line because you want to see them move. Yeah. Let me see if I can now bring back my plot and see some. Okay. So the first line will open the plot. Okay. Then I'll put the points there. It's not nice here. In R is bigger, so you see it's his big, yours is bigger. Okay, great. Then we put the absolute line, see the green, so that is the OLS, because the 50%. Even though it's R cubed, it's quantile regression, but it's going through the center because we put it 50%. And then we want to do the OLS itself. If they fall on each other, they should. Do they? They do. Oh. So now I want to plot all the 19 quantiles on the graph. And this is the line. This is a for loop. So we are running from the first quantile to the last one. That's how. So this is the equation. And this is the length that we want to run for. For what? Tau I. So I in 1 all the way to the end of whatever tau is. Then we put the I here. So, okay, I mean, this is not programming course. So let's That's how you should understand it. Okay. So this line, you can select them and run them together or one at a time. So let me see if my plots. Yeah, so this is what I've done. So come on, stay here. I never pretended. So the both are the different quantile. There was a green one, and we also did the empirical quantile, which is the red one. So you see, it's only we have not lost a lot of the data. If we do OLS, this one we do this one, everything else is not using, and we are missing a lot of information. But now we have all these relationships, and that involves policy of building. But that the relationship is not just one relationship. It's different. So if you have policy and investment, you need to take the investment based on the prevailing market conditions. When we are in bullish market conditions, what is the relationship? What is the market? Maybe it's positive or negative, but the magnitudes are the same. So you are holding your investment based on what the sign of the relationship. So this is the quantile regression for you. Let's say QR2. If I take intercept out, QR2, right? I just need to do -1 here. And this is universal. But you don't need the space. It will work. Once it's -1, it will work. So once you put that there, you remove your intercept. So if you have good reason to remove the intercept, that is your QR2, and QR2. So let's see. And you realize that we no longer have the intercept. To be clearer here, I'll show you. So let's do the QQR, show you where it starts from. So if you look at this one here, this is just a test to see if the coefficients are the same or not. Yeah. Yes. In fact, you may want to add it to your output. It doesn't hurt. It's a further confirmation that the so there are 19 of them. That are all of them. If you don't have the same, you find that but you have you can pick out any, can pick 0.1 and 0.95. If some are going to vary, the likelihood of something is still be the ones that are very close. It's possible that. So once you set them out, you can pick out which ones to test. Pick all of them. Yes, it's a joint. In fact, it's called, they have different types. This is the joint test. It's also the word test of similarity of coefficients. They also have one called the symmetry of coefficients. That one is very popular in EVs.